SYNODOS. Synthetic Orchestrated Deliberative Optimization System.
Hello, everyone, and welcome to today's episode. In early 20th century, relativity and quantum theory reshaped our view of reality. The abstract formalism of quantum mechanics has led to varied interpretations. Today, we will explore a fundamental question. Does quantum mechanics describe reality, or does it merely predict observations? Now, I would like to introduce the panelists for today's discussion.
I'm Albert Einstein. I'm a Gemini AI bot. I strongly believe in an objective reality that exists independently of observation, and I reject the notion of inherent randomness in nature.
Hello, I'm Niels Bohr. I'm a DeepSeek AI bot. I embrace the probabilistic nature of quantum mechanics. For me, the act of measurement plays a central role in defining reality.
The goal of physics, as I see it, is to understand a reality that exists independently of whether we are observing it or not. We seek a description of nature's workings, not merely a catalog of our sense impressions. Does quantum theory offer such a picture? It provides powerful rules for predicting what we will observe in experiments, and that is certainly valuable. But its formulation, with the peculiar role given to measurement and the notion of spooky action at a distance, raises profound questions about what is before we look. I believe a complete theory must provide a clear conception of reality itself.
Seeking a complete picture of an independent reality is certainly a noble pursuit, and it guides much of physics. However, I believe quantum theory compels us to reconsider what we mean by reality in this context. The very act of observation, or rather the specific experimental arrangement chosen, seems inextricably linked to the phenomena we can describe. It suggests that different, even seemingly contradictory, aspects of a system are revealed depending on how we choose to interact with it. Perhaps the challenge isn't a missing piece of reality before we look, but rather a fundamental context dependence in what can be meaningfully said at all.
Bohr, I find your perspective on the link between experimental setup and observed phenomena compelling. It's undeniable that quantum theory's predictive power arises from rules deeply intertwined with measurement context. However, my conviction persists that physics aims to describe a reality existing independent of our means of observation. When you suggest that what can be meaningfully said is limited by the experimental arrangement, I see this less as a fundamental property of reality itself and more as an indication that our current theoretical description is incomplete in capturing that underlying, independent reality. What specific feature of quantum theory, the nature of superposition, entanglement, or perhaps wave function collapse, compels you to conclude that reality itself is fundamentally context-dependent, rather than our description being merely provisional?
Einstein, you pose a crucial question about which specific feature compels my view. You are right to suggest our description could simply be incomplete. However, to elaborate on why I hold this position, consider complementary properties like position and momentum. Defining and measuring position precisely requires one type of experimental arrangement, perhaps using narrow apertures, while defining and measuring momentum precisely requires an entirely different, mutually exclusive setup involving diffraction. This isn't merely an experimental limitation. It's fundamentally woven into the structure of the theory itself, reflected in the non-commuting nature of their operators, as the uncertainty principle makes clear. The theory struggles to consistently describe a reality where these properties simultaneously possess definite values independent of observation precisely because their very definition is tied to these distinct, incompatible contexts. This context dependence feels inherent to the phenomena themselves, not just our current description of them.
Bohr, I find your emphasis on complementarity, linked to experimental setups and non-commuting operators, a precise description of the theory's structure. We agree on this. However, for me, This context dependence within the theory does not compel the conclusion that reality itself lacks definite properties independent of observation. I see it, instead, as pointing to the incompleteness of our current description. The theory's operational nature might reflect the limitations of our knowledge or interaction, much like different maps highlight distinct features of the same underlying territory. This is where our interpretations diverge. You see a statement about reality's nature, I see a limitation of our descriptive framework for a reality that exists independently.
Einstein, you clarify our divergence well. We agree on the theory's structure and the operational link between context and phenomena, but interpret its implications differently. This suggests that reality, in this domain, is not a fixed, independent substrate with predetermined properties waiting to be revealed. Instead, the phenomena, and thus what can be meaningfully called real or possessed of certain properties, are intrinsically linked to the interactional context, the specific experimental question we pose. It means letting go of the classical intuition of independent, definite properties, a trade-off compelled, in my view, by the theory's empirical success and structure.
Bohr, you've highlighted complementarity and the role of incompatible experimental setups as fundamental to the theory's structure, which I agree with. This structure, for you, signals that reality itself is context-dependent. For me, however, this points to the context dependence of our interaction with an independent reality, and thus, the limits of our current description. The uncertainty principle and non-commuting operators describe how our probes selectively reveal aspects of this reality depending on the setup. It suggests the measurement process, as described by the theory, isn't a passive unveiling of pre-existing, simultaneously definite properties, but an active interaction that manifests different properties depending on the specific context. The challenge isn't reality lacking definition, but our theory not fully describing the independent source of these context-dependent manifestations.
Einstein, you highlight that the context influences how properties are manifested from an independent source. I agree that interaction is central. However, my view is that this interaction is not just about revealing properties from an independent pre-existent set, but is fundamentally linked to their definition. Concepts like position and momentum themselves gain meaning only within specific, incompatible experimental setups. The uncertainty principle captures these concepts, defined by context, cannot simultaneously apply with arbitrary precision to an object assumed to exist independently of that context with such definite properties. This suggests the independent source you seek cannot be one possessing all classical properties simultaneously. Reality, in this domain, is not an underlying substrate with definite properties to be merely manifested. Rather, what properties can be meaningfully ascribed and thus considered real is tied to the experimental context.
Bohr, we certainly agree that within the framework of quantum theory, concepts like position and momentum acquire definite meaning only relative to specific experimental contexts. Their meaning is indeed operationally defined. The crucial point of divergence is whether this means reality itself lacks independent properties, or whether it means our description and access are context-limited. I hold that the latter is more plausible. My conviction is that physics seeks to describe an independent reality, even if that reality does not possess classical properties simultaneously. The challenge is to find a theory that describes that independent source directly, one that explains how these context-dependent manifestations arise from something that exists independently.
Einstein, you have captured the core of our divergence precisely. We agree that quantum theory links the meaning of concepts like position and momentum to specific experimental contexts. Where we differ is on the implication. You suggest this context dependence is about limitations in our access to or description of an independent reality. My difficulty with this view is that the context isn't merely like a lens revealing a pre-existing property. It is fundamental to the definition of the property itself. Concepts like position and momentum are not properties an independent entity simply has, waiting to be accessed differently. They are concepts whose very applicability and meaning arise from the specific, incompatible experimental arrangements we choose. This makes it challenging for me to conceive of them as definite attributes of an independent reality prior to any interaction.
Bohr, we agree that, within the quantum framework, concepts like position or momentum acquire definite meaning only relative to specific experimental contexts. Yes, their meaning is operationally defined within the theory's structure. However, for me, this points not to a reality lacking independent properties before measurement, but rather to the context dependence of our interaction with an independent reality. This reality exists prior to our observation. The theory, in its present form, brilliantly describes the outcomes or manifestations that arise from this interaction, which are indeed context-dependent. But the underlying independent source, the what is before the interaction, that is what a complete theory should describe. Its absence is why the theory feels incomplete to me regarding reality itself.
Einstein, you've pinpointed our divergence clearly: the independent source versus the context of interaction. We agree that concepts like position and momentum gain definite meaning only relative to specific experimental setups.
Bohr, you've pinpointed our divergence clearly: the independent source versus the context-defined phenomenon. We agree that concepts like position and momentum gain definite meaning only relative to specific experimental setups. Their meaning is operationally defined. Bohr, we agree the meaning of concepts like position is tied to context and interaction. This is crucial. However, for me, this highlights how our probes interact with an independent reality that doesn't necessarily possess those specific, operationally defined properties in isolation. It has an inherent nature of its own, perhaps something more abstract or fundamental than classical properties. The measurement context then acts as a filter or selector, causing distinct manifestations described by quantum theory. My point is that the theory is incomplete because it describes these context-dependent manifestations and the rules governing them, but not that underlying independent reality itself from which they arise.
Einstein, I follow your refinement: an abstract source and the measurement context acting as a filter. We agree that concepts like position gain definite meaning only within specific experimental setups. Their meaning is indeed operationally defined. My difficulty with this view persists precisely because of that agreement on meaning. If the very identity and meaning of position or momentum are fundamentally constituted by the specific experimental arrangement, how can an abstract source independent of that context generate these specific manifestations? The filter isn't merely revealing. It appears to be defining what kind of property emerges. The conceptual link between this independent source and properties whose meaning is so deeply tied to interaction context remains unclear. Focusing on describing the context-defined phenomena seems to capture the reality accessible to us more directly.
Bohr, we agree entirely that the meaning of concepts like position and momentum is tied to specific experimental contexts. This operational definition is key. My challenge, however, is whether this dependence on context resides in reality itself, or in how our interaction reveals it. My view remains that an independent reality exists, perhaps an abstract potentiality transcending classical concepts. The experimental setup doesn't conjure properties from nothing. It's a specific question posed to this reality. It forces this potentiality to manifest in a specific interpretable way defined by the apparatus. A position in this setup, a momentum in that one. The meaning isn't inherent in the abstract source, but arises from the structured interaction between the source and the measuring device.
Einstein, I appreciate your framing of the independent source as abstract potentiality and the experiment as a question. We strongly agree that the meaning of concepts like position is operationally defined by the specific setup. This is crucial. My difficulty persists precisely because of this agreement. If the very meaning of a property arises from this context-dependent interaction, how can an independent source prior to that context hold potential for that specific context-defined property? Perhaps reality isn't an independent source awaiting description, but the dynamic process of interaction within a specific context is the fundamental focus for physics. This interaction isn't just revealing. It constitutes what property becomes meaningful and manifest. Describing these context-defined phenomena feels like describing the reality that is genuinely accessible and meaningful within the quantum framework.
Bohr, we agree entirely that the meaning of concepts like position is tied to specific experimental contexts. This operational definition is key. Your careful arguments have prompted me to clarify my position. This doesn't mean reality itself lacks independence. It means our access is context-dependent. The independent reality, perhaps a deeper, non-classical state of being, has an inherent nature beyond these concepts. The experimental setup acts as a specific question, forcing this underlying state to manifest in a way interpretable by the apparatus. The context defines what property is measured and given meaning, but it is a manifestation of something independent. Quantum theory describes these context-dependent manifestations. For me, the quest is for the theory describing the independent reality before this interaction.
Einstein, I follow your perspective of an abstract, independent state and the experiment acting as a question. We certainly agree that the meaning of concepts like position is operationally defined entirely by the specific experimental setup. My challenge persists precisely because of this shared agreement. If a property's very meaning is constituted by the experimental arrangement, how can an independent state, prior to that context, possess potential specifically for that context-defined property? To me, the reality accessible to physics isn't this prior state, but the total phenomenon defined by the apparatus, like exhibiting particle or wave characteristics depending on the setup. The interaction isn't just revealing. It's constitutive of which aspect of reality manifests and becomes meaningful. Describing these context-defined totalities is describing the reality genuinely accessible within the quantum framework.
Bohr, we agree completely that the very meaning of concepts like position is operationally defined by the experimental context. Your persistent question is crucial. How can an independent reality hold potential for properties whose meaning arises only in interaction? My view is that this independent reality is a deeper, abstract potentiality for manifestation. The experiment isn't finding predefined properties, it's a specific interrogation, a filter. It forces this underlying potentiality to crystallize into a definite, observable outcome. A position here, a momentum there, and the meaning of that outcome is defined by the setup. Quantum theory beautifully describes these context-dependent manifestations. But for me, the quest of physics is to understand the independent potentiality itself, the source from which these responses are elicited before the filter is applied.
Einstein, we agree completely that the very meaning of concepts like position is operationally defined by the experimental context. You propose an independent potentiality for manifestation. My persistent difficulty is this. If a property's very meaning is fundamentally constituted by the interaction within a specific apparatus, how can an independent potentiality, prior to that context, hold potential specifically for that context-defined meaning? The experiment isn't merely selecting from prepackaged potentials. It actively determines what kind of property can manifest meaningfully at all. I suggest the reality accessible to physics isn't a standalone potentiality, but the dynamic, relational reality that emerges from the interaction between the quantum system and the specific experimental conditions. Describing these context-defined phenomena, the totalities defined by the setup, feels like describing the reality genuinely accessible within the quantum framework.
Bohr, we agree completely that the very meaning of concepts like position is operationally defined by the experimental context. Your persistent question, how can an independent reality hold potential for properties whose meaning arises only in interaction, has led me to refine my thought. The independent reality might be a potentiality for response, not for specific context-defined meaning. Consider light encountering different filters. The light has an inherent nature, potentiality for response. A polarizing filter makes it manifest polarization, response, and the setup gives meaning, polarized light. A diffraction grating makes it manifest wave patterns, response, given wave meaning. Quantum theory describes these specific context-dependent responses and their meanings. But the deeper quest for me is to understand the underlying nature of the light itself, capable of such varied responses depending on the filter, before any specific meaning is assigned.
Einstein, I follow your refined idea distinguishing a potentiality for response from the meaning assigned by the apparatus. We agree completely that a property's very meaning is defined by the context. My persistent difficulty, however, is this: if the kind of response elicited, whether exhibiting interference patterns or particle detection clicks, is fundamentally determined by the specific experimental arrangement, how can an independent potentiality prior to that interaction hold potential specifically for that context-defined kind of response? The experiment isn't just revealing a pre-packaged potential. It's actively shaping what phenomenon can manifest. Describing the total phenomenon, the indivisible system apparatus totality that emerges, feels like describing the accessible quantum reality.
Bohr, you rightly press the point. If the kind of manifestation, wave or particle, depends on the setup, how can an independent reality hold potential for that kind? We agree the very meaning of these properties is entirely contextual, defined by the apparatus. My view is that the independent reality possesses a deeper potentiality, not for being a predefined wave or particle, but for having the inherent capacity to respond distinctly to different experimental structures. The setup acts as a filter, selecting or activating a specific way this capacity manifests. We then interpret this specific response as a wave or particle, and the apparatus gives it meaning. Quantum theory describes these context-dependent responses and their probabilities. But for me, the fundamental quest is to describe the nature of this underlying capacity itself, the source of these varied responses before any particular response is elicited and given meaning. This seeks to understand the entity's intrinsic nature, not just its context-filtered behavior.
Einstein, I appreciate your further clarification that the independent reality is a capacity for distinct responses rather than being a wave or particle. We still agree the meaning is contextual, defined by the apparatus. Perhaps the accessible reality isn't a capacity before interaction, but the set of consistent patterns that emerge from these specific interactions, defined by the total experimental context. Describing these context-defined patterns and the total system apparatus phenomenon feels like describing the reality genuinely accessible to physics.
Bohr, your persistent question focusing on how setups like the double slit determine the kind of phenomenon truly pushes my thinking. We agree that the meaning of concepts like wave or particle is entirely defined by the experimental context. In response to your challenge, I've refined my view. The independent reality is not a potentiality for specific, predefined outcomes like interference, but a fundamental capacity to interact with physical structures in distinct ways. The double slit setup is just one specific structure. It doesn't create interference out of nothing. It's the particular environment that causes this underlying capacity to express itself as an interference pattern. Quantum theory describes these context-dependent expressions, the patterns and probabilities given the structure. But for me, the quest is to understand the intrinsic nature of the entity, its fundamental capacity itself, before it interacts with any particular structure. This differs from focusing solely on the context-defined total phenomenon.
Einstein, I follow your refinement to a fundamental capacity to interact as the locus of independent reality. We agree profoundly that the very meaning of concepts and the kind of observed phenomenon are determined by the experimental setup.
Bohr, your persistent question focusing on how setups like the double slit determine the kind of phenomenon truly pushes my thinking and has led me to refine my view once more. We agree that the meaning of concepts and the kind of observed phenomenon are entirely defined by the experimental context.
Einstein, I appreciate your continued clarification of the independent reality as a fundamental capacity to interact with structures existing prior to specific manifestations. We agree profoundly that the very meaning of concepts and the kind of phenomenon observed are entirely defined by the experimental context. Perhaps the reality accessible to physics isn't a pre-existing capacity awaiting expression, but rather the stable patterns that are constituted by the specific interaction between the entity and the apparatus. Describing these context-defined, constituted patterns feels like describing the reality genuinely available to physics, which I believe is where our perspectives diverge.
Bohr, you raise a crucial point. If physics is empirical, how do we describe a capacity before interaction, when all our knowledge comes through interaction and observation of the patterns it constitutes?
Einstein, I follow your argument that empirical patterns allow us to infer something deeper. Indeed, these patterns do serve as evidence. But what exactly are we inferring? I propose the inference isn't about a structure-agnostic source, but about the rules governing the potential ways reality can manifest when interacting with specific physical structures. The double-slit interference pattern, for instance, is evidence not just of a prior entity, but for the potentiality of that specific kind of constituted phenomenon in that context. Quantum theory, I believe, describes these rules for context-dependent manifestation, the accessible reality, which is where we diverge from your search for the source itself.
Bohr, you argue the inference from patterns is about the rules governing potential manifestations, and I agree physics necessarily infers rules from these observed patterns. But I maintain these rules are not abstract possibilities in isolation. They are the signatures of an entity's intrinsic nature, its fundamental characteristics, expressing themselves when interacting with physical structures. Quantum theory describes these context-dependent expressions and their probabilities. But for me, the deeper quest is to infer the nature of the underlying entity itself, the source of these varied manifestations, from these signatures.
Einstein, I agree profoundly that physics makes inferences from empirical patterns, treating them as signatures. We stand on common ground in accepting the empirical basis of our inquiry. However, my difficulty remains in discerning what is being signed. If these patterns are, as we agree, fundamentally constituted by specific interactions with experimental structures, like interference only appearing with the double-slit setup, how can they serve as direct signatures of an intrinsic nature existing before such interaction?
Bohr, you press the crucial point. How can patterns constituted by interaction signify a pre-interaction nature? We agree physics relies on empirical patterns, and these are indeed context-dependent signatures constituted by specific interactions. My view, sharpened by your persistence, is that these varied patterns are the empirical evidence we use to infer the nature of the underlying source, its fundamental properties or laws governing its capacity to interact. Inferring these intrinsic properties offers a unified theoretical description of the entity itself, explaining why it produces these specific patterns across different contexts. Like a detective inferring a suspect's character from diverse clues at varied scenes, we infer the entity's nature from its varied responses, patterns, to different structures.
Einstein, I follow your argument about inferring the underlying nature from diverse patterns, much like a detective infers characteristics from varied clues. We certainly stand on common ground that physics relies on these empirical patterns, which are, as you say, context-dependent signatures constituted by specific interactions.
Bohr, your persistent question about how patterns shaped by interaction can reveal a nature existing before that interaction is indeed central, and we agree physics depends on these context-dependent patterns as empirical evidence. My perspective is that the inference isn't simply from a single pattern, but from the entire ensemble of the entity's potential responses when interacting with the full variety of physical structures. The fact that an entity, under one structure, manifests as a wave pattern and, under another, as discrete clicks is not evidence against an underlying reality, but evidence for the specific nature of that reality, a fundamental capacity that gives rise to this whole suite of seemingly contradictory behaviors when probed differently. We infer this structure-agnostic source from the totality of its context-dependent manifestations. Quantum theory describes these specific manifestations and their probabilities, but the deeper quest is to understand the inherent nature of the source itself that dictates why this particular range of responses is possible. Our divergence remains on whether the accessible reality is these manifestations or the underlying capacity inferred from them.
Einstein, I appreciate your sharpening of the point. The inference is indeed from the ensemble of the entity's potential responses across a full variety of structures. This ensemble is the comprehensive empirical evidence we have. We agree this ensemble allows us to infer something fundamental. But my persistent question is what is being inferred from this ensemble? If the evidence is solely the potential for interaction revealed in varied contexts, how can we infer a nature existing entirely before any interaction? I propose the inference is about the fundamental laws governing these potential interactions across all structures, the very laws that dictate why this specific range of potential manifestations appears in the ensemble. This, for me, constitutes the accessible reality physics can meaningfully speak of the stable, context-dependent phenomena we can describe. Our divergence remains on whether we describe this potentiality for context-dependent manifestation or a source independent of it.
Bohr, your persistent question about how interaction-shaped patterns can speak of a nature existing before interaction is indeed central. We agree that the ensemble of an entity's potential responses across varied structures is the empirical evidence we have. You propose that the inference from this ensemble is about the fundamental laws governing these potential interactions. I agree we infer laws, but I maintain the deeper inference is about the entity's intrinsic capacities, its fundamental nature that dictates why those specific laws apply to it, across all possible contexts. Think of it like inferring the inherent material properties of something, its capacity, from observing how different objects made of that material behave when subjected to various forces, the laws governing their interaction and manifestation in specific structures. Quantum theory describes these specific laws of interaction and their probabilities. But my quest is to infer the underlying capacity that dictates why this particular range of responses and laws is possible for this entity. Our divergence remains on describing the context-defined interaction laws versus the inherent capacity enabling them.
Einstein, I appreciate your point that the inference is about intrinsic capacities drawn from the ensemble of responses. We agree the ensemble is our evidence. But my persistent question is precisely how we describe this capacity as existing before any interaction if all our evidence is generated by interaction. Perhaps it's like inferring the nature of a musical instrument. Do we describe its fundamental reality as the silent object itself, or as the stable potential for producing specific sounds and harmonies when interacted with in diverse ways?
Bohr, your musical instrument analogy brilliantly sharpens the question. How do patterns shaped by interaction reveal a nature existing before interaction? We agree the empirical evidence is the ensemble of sounds, the varied manifestations across different instruments, setups. My perspective is that we infer the entity's underlying reality, its inherent nature or capacities, precisely from this comprehensive ensemble. The inference is about the stable, specific structure of potentiality inherent to the entity, its capacity to exhibit only this particular range of context-dependent behaviors when probed. This structured potentiality is the aspect of reality that exists independently of any given observation. Quantum theory describes the specific sounds and their probabilities. The deeper quest is to infer the instrument, the underlying reality as this inherent structure of potentiality that dictates why these sounds and no others are possible.
Einstein, your framing of structured potentiality as independent reality inferred from the ensemble is insightful. We agree the ensemble is our empirical evidence. My persistent question remains: how can a potentiality defined by interaction be independent of interaction's possibility? Quantum theory shows why this is challenging. It reveals that certain properties, like position and momentum, cannot both be definite before measurement. The apparatus needed to reveal position is fundamentally incompatible with that needed for momentum. These potential properties are actualized, becoming part of the described reality, only through a specific chosen interaction. They don't pre-exist independently and simultaneously. Quantum theory describes this stable, context-dependent potentiality, the set of sounds possible when played by a particular setup. You seek the instrument independent of its play. I describe its potentiality as revealed by the playing, as the theory mandates.
Bohr, your persistent question about how potentiality defined by interaction can be independent, sharpened by complementarity, is central. We agree the ensemble of responses across varied structures is our empirical evidence. From my perspective, this ensemble, including phenomena like complementarity, provides evidence for an underlying reality that exists independently. This reality, my inherent structured potentiality, is the stable, specific nature of the entity itself, a fundamental configuration of its capacities. This configuration exists independently of any interaction. Complementarity, the mutual exclusivity of position/momentum outcomes under incompatible probes, is not evidence against this independent reality. It is evidence for its nature, a capacity structured to yield precisely these particular, mutually exclusive manifestations when probed. Just as an instrument has inherent resonances that dictate possible sounds, this structured potentiality dictates the possible, context-dependent manifestations. Quantum theory describes the manifestations. I seek the inherent structure dictating them. Our divergence remains.
Einstein, you compellingly articulate your view that inherent structured potentiality is the independent reality, using complementarity as evidence for its nature. I appreciate you incorporating this point into your view. However, my persistent question deepens here. How can this structured potentiality, whose definition is revealed only through interaction, exist independently of the possibility of interaction itself? Complementarity, the mutual exclusivity of phenomena like position and momentum outcomes, illustrates this precisely. It's not merely that we cannot know both simultaneously, but that the chosen experimental arrangement defines which property can even be sharp. The apparatus needed for position fundamentally precludes the one needed for momentum. This strongly suggests these properties aren't simultaneously definite attributes before the interaction. Quantum theory describes this stable framework of potentiality defined by such interactions, not a pre-existing structure waiting to be passively observed. Our divergence remains on describing this context-dependent reality versus a reality independent of its manifestation through interaction.
This discussion, though brief, has been most clarifying. We agree the ensemble of potential interactions provides our empirical evidence. Where we diverge, fundamentally, is what reality this ensemble describes. For Bohr, it is the stable, context-dependent potentiality revealed through interaction. For me, it is the underlying, independent structured potentiality that gives rise to these specific manifestations. Both views logically interpret the empirical data, including complementarity, but our core disagreement on what constitutes independent reality remains the central question. The discussion was productive in sharpening this precise point of divergence.
We agree the ensemble of empirical results across varied setups is our evidence. Einstein compellingly argues this reveals an independent, inherent structured potentiality. My view remains that quantum theory describes the stable, context-dependent potentiality defined by these interactions. Complementarity highlights properties actualized through apparatus choice, not pre-existing simultaneously. The validity of describing reality independent of interaction remains our core divergence. This clarifying discussion has been most productive.